on the plot that could be miles and miles away if the soil and the water carried downstream by the river. So some of the indicators, we're always talking about indicators, measurable indicators. If we look at the splash erosion, this is something difficult to measure. It's not splashed very far away, but as soon as we have erosion features such as these rills or those gullies, it can be as bad as this one. Then we have difference in quality. We have a higher transportation distance compared to sheet erosion. And at the same time, we have some indicators that we can map or measure, and that way find out what is the order of magnitude of soil erosion. So talking about orders of magnitude is just an example from Switzerland. We talk about tons per hectare and year. So we have two of our study sites, Fliensbeck is the study site included here. Now if we would average soil loss over all plots that we measure, let's say per year, we have only 1 ton soil loss per hectare a year. That's not much. But there could be single plots with more, such as 22 or even much more, depending on the rainfall distribution. So we see it can be very different from site to site, even if they're only a few kilometers apart. That's one thing, so it's very heterogeneous here. Second, if we look at the percentage of sheet erosion, rills and gullies, for example, that can also vary. So those figures given here are average values, and the question here is, what is the use of it? It could be good at the European level to indicate differences between regions, but it's not very successful in promoting measures or finding out what are countermeasures, what are soil conservation measures. So, and that brings me to the assessment methods here. I see Switzerland as a white spot. That doesn't mean that we don't have a map. We have probably a different model, and it's, I think, outside of that project. But it would be nice if we could convert our model. Now we have one, we have also, I think, this, I don't know, this model, Pesera, is it based on the universal soil loss equations? No, not at all. We have one based on that, but we have a 2 by 2 meter resolution digital terrain model, so that is quite detailed. But anyway, here we have soil erosion tons per hectare per year. And you can see all over Europe, you can say where are the hotspots, where are the areas where action needs to be taken. So for decision making, this is a very good basis.
But what you said before is that even in the green areas, you will still have red spots.
You can have, yes.
So
you can have, yeah.
So action should be taken all over.
Well, that depends. I mean, locally, you must have conservation services, experts, researchers who know where the hotspots are. I'm going to show that using some of the case studies we are looking at. But those models need to be fed with data, and they need to be calibrated. So we need a number of measurements. Not to go too much into detail here. The typical ones, some test plots, rainfall simulations, gauging stations. The problem here is they're all very costly. You need a lot of equipment, you have a high demand of personnel here. So very often what happens to smaller projects with lower amount of money is rill mapping. So you are looking at the rills. You cannot determine sheet erosion, you look at the rills and measure the volume and convert it into soil mass which is moved away, which can give you at least a semi-quantitative data as well, but also qualitative data is very useful here. So measuring soil erosion is one thing. What is the effect of soil erosion? The soil functions, of course, the supporting ecosystem service. If we look at soil formation, soil fertility, organic matter, soil hydrology, all those functions are affected, more or less affected, severely affected by soil erosion. And I see the others here as a consequence of that. Consequently, you may have reduced production, you may have a problem with fresh water, or here in the regulating function, flood regulation, water purification, maybe problems, maybe not. And depending where you are, aesthetic or recreational function. For example, Switzerland as a country heavily relying on tourism. You know, if you have the muddy roads, that's not appreciated neither by the Swiss population, nor by the farmers, nor by the tourists. So I leave it at that stage. It will be different from case study to case study, which of the functions are affected and to what extent. I think in this respect it is wise to distinguish the effects of soil erosion into on-site and off-site effects. On-site erosion in many areas is related to production, crop production, agricultural production, not only but in many areas. So the rain that falls on the site, you lose soil fertility, may decline crop production, you destroy infrastructure, polluting watering points, etc. These are the on-site effects, but then the sediment and water are carried further down. There is sedimentation of water reservoirs, flash floods, water pollution, things like that. So this distinction of the effects of soil erosion is quite important because it involves costs. Those are costs related to the farms, the farmer. There's the cost of lowered production, destruction of infrastructure, or even pollution, like you have your sediment on the roads. In Switzerland, that's a couple of thousand Swiss francs to clean the road, and this is a special waste. You cannot drop it somewhere. You know, it contains fertilizer and chemicals and so on and so forth. So destruction of infrastructure is costs for the community, and that may be costs for the society. So look, if we are discussing about what are cost and benefit analysis, we can use probably some differentiation like that one. Now coming back to that map, the question here is what can we do about it? What can we do against soil erosion? And now, as I said, this map first of all tells us where some hotspots are at a very broad level, and we have to see our 3 case studies. Sorry, I did not introduce, this is a common presentation of Adriana and Jakob and myself. And these are our case study sites. So we are dealing with forest fires and post-fire erosion management in Jakob's case, abandoned terrace management in Cyprus, also a white spot on the European map, and Switzerland. So we have still white spots on the map, but we could at least use such a map to go into areas with more severe erosion hazard, apparently. But we have to go further down. Or another question here is, we discussed it yesterday at the political level, what would be a potential threshold for tolerable soils? I personally believe this is nothing that comes out of research. Even if I would be able to determine, to compare soil erosion with soil formation, say this is the threshold level. I think since it affects a policy, it needs negotiation. So for me, this is negotiable. But the data, the basic information, can come from our side, and then of course involvement of policymakers at an early stage. That's why I made the comment yesterday. Now I think I have still 5 minutes. Good. If you want to have an overview of conservation measures, I refer to WOCAT. Godert will be happy to introduce that to you in a couple of days. So I will restrict myself a little bit to Switzerland, Portugal and Cyprus, and give you just some hints, because there's too much to be presented in 5 minutes. Now let's go to Switzerland first. The question was, where in the hot spots of Switzerland, or in the green spots of Switzerland, where should we start? And in Switzerland, it's mostly related to crop production in the hilly area. That's soil erosion. You know, and in here, then the question is in detail, what are the key factors? Where are the hotspots? What are the accelerators? For example, headlands, wheel tracks, field border furrows. You see, soil erosion in Switzerland is a consequence of compaction in very many cases. So here the first question is, where is the damage? Then what are the reasons for the damage? And not to forget that upslope we have sources of runoff, well-protected areas which still can produce runoff that causes erosion somewhere else. And then we have the offsite damage, also involving costs. So treating erosion is not only the responsibility of the farmer, for example, to do something on his farm. It's a societal problem. So that opens up the range of stakeholders involved. But in our case, one of the measures that was not promoted by us but by Swiss agencies of agriculture is zero tillage. So you don't plow, and this means it's not a conservation measure. You have to manage the system. The system, you manage the water. It's erosion by water. So you manage the water by managing the soil, the vegetation, the livestock, and the slope. You know, it's not, you cannot just look at the soil. And no-till, you can see here, this is a few meters apart. This is conventionally plowed field. This is a no-till field which is very well protected. So no-till is not a conservation technology, it's a different farming system. So in order to adopt it, a farmer has to change everything: livestock management, crop management, pest management, and so on and so forth. So I don't see us recommending farmers measures from the book, you know. So there is a development process with stakeholders here. And with that, coming to the end, Portugal, post-fire mulching, you see erosion as a serious problem, not throughout the year, but especially after clearing the forest through forest fires. And mulching, I think these are plant residues, covering the soil here and increasing the vegetation cover and thus preventing erosion. That's a completely different management system.